So we have the next session, and the title is Spark Use Case. Spark Use Case at Telefonica Cybersecurity. We have two presenters, joint session. We have Frank, and we have also Oscar from Stradio. All right, so I'll leave you guys with these two fine gentlemen, and if you have any questions after that, let us know. Oh, you can go with it, or you want
So we are going to use Spark technology in a real project, big project for one of the five more bigger companies, telecom companies in the world. So Frank will explain the business case, the project, and I will explain how we implemented the project using Spark. So please, Frank.
Thank you. I used Okay. We can start. So I want to start at the beginning with the why, because how many people here knows what the meaning of cybersecurity? One, okay. But how many people here knows why cybersecurity exists? Why we have cybersecurity services? I think that if you know what the meaning of a thing, you can define it. But if you know why a thing exists, you know the problem and you can solve the problem. So to explain the why of cybersecurity, I usually use an example, and the example is a scene of a film. I think everybody knows Forrest Gump. So that's the scene. Please. Okay.
Man! Hey, listen, I was wondering if you might help me, huh? Listen, I'm in the bumper sticker business, and I've been trying to think up a good slogan, and since you have been such a big inspiration to the people around me, I thought you might be able to help me jump into... Whoa, man! You just ran through a big pile of dog shit!
It happens.
What, shit?
Sometimes.
And that is why cybersecurity exists, because it happens. It happens. So the reality is that you must keep calm, because, it happens. Threats happens. Security holes happens. Data leak happens. And the important thing is that you know that it happens and you understand why it's happening. So now we know why cybersecurity exists, and now we can check what the meaning of cybersecurity. Here I have two definitions of cybersecurity, one for Internet Telecommunication Union and one from Department of Homeland Security. Okay. In the world, I think that every company have a definition of cybersecurity, everyone. The best is you can get one. So here, I think that the best is to create our own definition, and because I think that we don't have time, this is our definition for today speak. Cybersecurity is just a collection of tools. It's just capabilities to detect, to prevent all the security holes, all the security threats that in internet, and today's internet, we have as a company. So better than explain what a security hole is, or better than explain what a threat is, I think that the best form is to take an example, okay? So, again, out. And maybe, how many people knows what is Sodan? I think that's one. 2 persons, okay, 3 persons. Sodan is a big database where the content indexed is not the content of the web page, it's the content of the fingerprint of server of the IP. So here we have a search, Yeti 6.1, whatever, okay, and this is the server and the port that use Storm UI, okay? Storm UI is where you can see your topologies running, you can kill it, and unfortunately doesn't have a key or access management. And try to, okay, we are lucky. This is a topology running from a server of internet that I don't know who is the server is in Brazil. No, it's in Dublin, okay. So the problem is that you can kill this topology. So we can kill, no, I'm kidding. That's not good. Okay, so that's a simple example. Just you have your system without a pass. Just you have your system and internet, and everyone can enter in your system and kill your topologies. Or better, how many people knows what's the step between, between the use of a WordPress intended or the use of WordPress in a denial of service? Okay, so the difference is just a vulnerability. And the first step to detect a vulnerability is know the information of the server. And here, we have a lot of information. I'm so sorry, just an example. Then, more information. This is too information to an attacker to detect a vulnerability and exploit it. So, the important thing is that threats are simple or are complex, but the beginning of a threat, a data leak, or another threat is just a little misconfiguration, a weakness, a default password, something else. So I think the most important to understand the cybersecurity is the cybersecurity have two sides, the motivation and the threats. Here we have motivations that normally are hacktivism, cybercrime, cyber warfare, and cyber espionage. So in numbers, we have denial of service, SQL injection, defacement, account hijacking, and unknown. Okay, what is the best or the most important threat in this list? It's not the denial of service, it's the unknown. Why? Because unknown is all the things you can detect that you don't know. And there are the things that you can never detect if you don't know. So in my office, people that detect this type of threats are the Ghostbusters because they try to detect that ghost. The only thing you know is the result, the data leak, the database that is published on internet, anything else. So in Telefonica, we are working to change the traditional approach to a new approach, to change the security approach to cyber intelligence approach, change detection to analysis, change information to intelligence, etc. So current solutions are this type: have events, correlate, normalize, and create an engine to get alarms, to get audits. That's not enough to detect threats, complex threats. So in security, we are like these people. We don't have the tools. And we try to change this to get more context, behavior, anomalies. We need a lot of processing and storage. We need to get a lot of information from different sources, from different types, and in a stack, process, storage, and access to get early alerts, to get report, trends, etc. So we need a Skynet. As Skynet is just a film machine, we need to create our own Skynet, and then is where Telefonica meets Stratio. And Stratio help us to create our system to detect all these threats that nobody knows where are, who are, or what are. And then it's time to Oscar to explain the solution from Telefonica created by Stratio, or helps to create by Stratio. Thank you.
So now I will talk about Spark and how we build the platform. Cybersecurity, I think it is really cool to talk about security, so my talk will be a lot more boring, but I will try to make it fast. So at the end, this was that we were building. We, as Fran explained, we need a lot of storage capacity to storage almost any data, and here we are talking about hundreds and hundreds of terabytes. This is for us one of the keys of this project. We are talking here about the Spark technology in real production with one of the biggest telecom companies in the world, with terabytes of data in real time and batch storing analysis. For us, this was the challenge. So what was the solution? I have to explain here. We built this system, it was September last year, so still we didn't have a Spark streaming. And then we were combining Spark batch processing with Storm. And this was the technology, and we are evolving this. I will explain this. So we have three phases or 3 steps. The first one is to ingest the data. And here we are taking data from different sources and high volumes of data, mainly in real time. Then it was the data fusion that I will explain, and then the batch and analysis processing. So here we have it, data acquisition. Here we were combining data from different sources. The traffic, normal traffic from a telecom company with the IPs and all the data packages, and you can well understand or visualize the high volume of data that a telecom company can combine in a security system. And also, of course, with media sources for the leaking of documents, and also this about underground sources and government sources. We cannot talk about that, of course. No, but really there are a lot of underground and cyber attacks, and like black internet or underwear internet. So here we had a lot of information to combine into the system. And sometimes it was amazing because we were able to detect passwords for very big systems in production all around the world for any company. And that is really amazing, or credit cards or whatever. Things really quite impressive. So the second part, of course, we were combining here the sources with Kafka, and I think everybody knows Kafka, so I will not explain what it's doing. It's the boost for integrating the data. And the second step was the fusion of the data and mainly the real-time analysis and alerts. As I said, this project was made in September, so last September, a year ago, more or less. So we were using Storm to combine and to give the alerts in real time, and also at the end to store in the next step. And here is where we have Spark integrated with Cassandra. And as I said, this was 1 year ago. So really, we built the first Spark Cassandra integration in a real system in production with hundreds of terabytes working, and this was quite a challenge. So that we were doing was to put the data in Cassandra and then read with Spark directly from Cassandra, not Hadoop Common Interface or whatever, just in a native way. And one of the main benefits that we built was for single queries, or when you wanted to access the data following the schema that was in Cassandra, we were accessing directly to Cassandra with the Cassandra API. And of course, this is really fast, and you can have, well, several users reading the data, and this was very good. But when you wanted to do something like prediction or machine learning or a group by or a joint or anything that Cassandra API is not doing, then we were using Spark. So we had in the system this combination. When you wanted to access the data in Cassandra directly, because it was in the schema, and so Cassandra is really fast when you are making any query following the Cassandra schema, then it was fast and directly. And other way, you were able to do almost anything you wanted using Spark. So really this worked fantastically. The results were amazing. And this was the system. So for us, that we wanted to explain is what have we learned, lessons learned. First one, the Spark plus NoSQL database integration is a winning combination. No doubt about that. But there is a point here. The point is the NoSQL database, the NoSQL databases are very specialized. So don't use the same NoSQL database in all the cases. You have to adapt. There are some projects that it is better to use some database like Cassandra, but in other projects, maybe it is better if it is, for example, very close to internet or to e-commerce or recommendations or whatever. It is better to use MongoDB. In any case, you have to be really smart about what NoSQL database to use, to integrate with Spark. So what this project for our clients that we have built is a Spark distribution with a module that we have called Cross-Data Spark. This is something like a Docker station in which you can integrate any NoSQL database that you want. You can integrate, you can see there some examples, but we are able to integrate any NoSQL database in less than 4 weeks, but not with Hadoop Common Interface. As I said, it is a direct integration to the NoSQL database. And this has a lot of benefits because you can go directly to the API of the NoSQL database or go to Spark and make something well, a bit more sophisticated and do whatever you want with the data that is there. And this is really a powerful combination. The second one was, pure Spark. And this is really what we wanted to talk about. As I said, we made this project 1 year ago. And Spark streaming still was not available. But after that, we have evolved the system, and we are only using Spark in our platform. So we said that we are a pure Spark distribution. We don't use any Hadoop. We really like Hadoop because it was the beginning of big data, but in our platform, we don't use Hadoop, and I will explain why, and why this was one of the lessons that we learned. Okay. This is the reason. In that project, we were combining Spark batch processing, and still, I think, in that time, Spark was not in the Apache Foundation, so it was like a shift, very risky. I was not dreaming very well in that time, because Spark was just a promise in that moment. But the Spark MapReduce was amazing, so we decided to use it. But we have to combine it with Storm. To combine Spark with other technology is really very painful. You have to know 2 languages or 2 frameworks. If you want to combine Spark for the MapReduce with Storm or with, like in this case, or right now in other distributions, you want to combine Hadoop MapReduce with Spark streaming and with an interactive engine like Impala or Drill or whatever. You have to combine 3 different systems. And this is really very complex. So you are not fulfilling the promise of Spark, which is simplicity. Simplicity through an integrated framework. So that we have done is just use Spark. And this is the vision of Apache Spark. And this is that really we are trying to do, to help our clients just to use Spark, nothing else. So that we have done is to use only pure Spark and to integrate Spark over any NoSQL database in the market, the main NoSQL database is why. Because in the big data world, there are like 2 different fields. The processing, and the processing is solved because Spark is Apache Spark is a fantastic technology, and this is the reason I think we all are here, because we love Spark. But also the persistence. So that we have tried is to adapt to the persistence that the clients are already using, so they don't have to learn anything new. If they are already using Cassandra or Mongo or Couchbase or any persistent layer, we adapt to the one that they are using. And in this way, they only have to learn one thing, Spark, nothing else. So that we are trying really is to simplify things, to make it really simple. This is our platform. As you see, we have tried to make it even to look different because it is not the typical square with a lot of diagrams. It is like a sphere. But the main point, we are only using 7 components. All of them are open source, of course, but only 7, not 15 or 20. Because as you can see here, this is an hybrid distribution with Spark, Hadoop, whatever you're using here, several things. We can do the same just with 7 components, and this is Spark Power. So keep it simple, very lean. This is okay. It is maybe too much. But we didn't want to talk only about development. The other thing that we learned with this project, because we are talking about one of the biggest companies in the world, is that at the end you have to deploy the project. And to deploy a big data project is really complex. And if you have to combine technologies, it is like a nightmare. So that we were thinking was about deployment, about the system engineers. And this is that we have done to simplify, really simplify the deployment. And also, for the system engineers, that other of the lessons is, all right, you have finished the project, you have deployed, but now you have to manage the system because all the sources, all the data is coming in, and then you have to detect the threats and everything, so you have to support the system. And for this, you need an application. So we built an administration application to make the system engineers work a lot easier. And this is key. If you are going to put a Spark in production, you need an administration tool for sure. We are not here talking about proof of concepts. We are talking about big projects in production. So you need an administration tool for security, for everything. At the end, this is our conclusion. For developers, if you keep it simple, pure Spark with any NoSQL database, it is easier and faster, the development. So, right for developers. For system engineers, easier deployment. I don't know if someone has deployed a Storm architecture, but the topology really is complex. If you have to combine a Storm topology in a system with a Hadoop topology or a Spark topology, it is like twice the work and the effort. So just use one and keep it simple. The deployment will be easier, and also the support, because you only have to know or to support one engine, one technology, not 3 or 4 or 15 components. And at the end, for the clients, for the business, is to give them more value with less complexity, okay? That was our journey with this project. And this is working. This is really working. We are making big projects for very big companies, and if you can only use Spark, nothing else, with any NoSQL database. You don't need anything else. So this is really working, and if someone is interested, we really like to help any company making any development and to use just Spark, pure Spark. Upcoming challenges. What we are doing, and I think David, one of my colleagues, will explain tomorrow in one of the talks in the evening, is combining Spark streaming with a complex event processing engine. And this is like the next evolution or next generation for the streaming and ingestion. And this is one of the challenges that we are building. And in this project that we built was, because we were using a Storm, was in Symfonier. It was something graphic. You can, yeah, Frank, we will explain it. But for us, one of the keys to simplicity is to allow the developers or the system engineers or whatever to make things in a graphical way. So that here we are doing is to facilitate to ingest data or real-time data, just drawing the data. And this was made 1 year ago, and Frank will explain in a practical way.
Okay, one of the problems that we have in Telefonica is not all people have development skills, and for that we need to create a tool that simplify the creating of topologies and launch in the cluster. So as we start with Storm, we create Symfonier to Storm, and it's simple. You have modules, okay, spots and brains and bolts, and you have an editor where you can combine this and create topologies, and then launch in the cluster, where we are working to port this interface to Spark streaming. And at the moment, we are working with this, and analysts can create their topologies, and development are more have less work to do and are happy.
Yeah, as I said, simplicity is the key, and we think the next generation for big data tools is to work in a graphical way, very easy, not need to program, SQL integration, pure SQL integration with ODBCs, APIs, and visual tools, like this one, or like the one that we have seen in the keynote for Spark Cloud, which was a fantastic product. We think this is the way we started 1 year ago, visual tools to make it easier. So thank you. Any question?
Hi, I was just wondering if you'd be able to give a little bit of detail of the exact scale that you're able to achieve with Kafka for this kind of real-time ingestion. So you mentioned like terabytes of data per day. Like, are you into the 10s or 20s of terabytes? Like, how hard have you been able to scale it?
Could you repeat the question?
Yeah, just how much scale have you managed to achieve so far with the current ingestion in terms of terabytes per day?
Per day? Well, I don't have the exact figure.
We don't have this number here, and I don't know if I can say.
Okay. Or even number of events per day?
Yeah, well, I think we are keeping only 2 months of historical data.
Okay.
So it could be more than 2 months is 40 days, and 100 it is more than 3 terabytes per day or something like
Okay.
this that we are ingesting.
Cool. Thank you very much.
Any more questions?
So when you transitioned your Strat.io platform from using Storm for real-time processing to using Spark streaming, what are some of the things you noticed, and how would you compare their performance or the feature set, and what are some of the challenges you faced?
Sorry, what are?
What are some of the challenges you faced and some of the observations when you compared Storm and Spark streaming?
Well, for us, the main point about to make this transition, the visual tool is more or less is the same or very similar. But for us, one of the benefits of Spark streaming is only one framework. And I didn't explain this, but one of the challenges is to combine batch storage data with streaming data in real time entering into the system, but from a single SQL sentence. I mean, with the Spark streaming, you can make any SQL, select or query anything you want. But the real challenge for us is in the same sentence to combine batch storage data with real-time data entering into the system. So we have had to build something called ephemeral tables. Ephemeral tables are data that is entering, and we are creating on the fly these ephemeral tables, and then you can combine the batch with the real time just using SQL, nothing else. And this is one of the main benefits using Spark as an integrated framework, but of course that is not an easy task. And this is our challenge, to combine this in a really easy way, to make it very transparent to the developers to use Spark for batch and for streaming.
But how did you notice any performance differences? Did you do any comparison between Storm and Spark streaming?
Ooh. Well, for us, Storm is really complex, the topologies and the deployment, and also even to use the API and the language and the vaults and so on. But in the other way, we have built a lot of different sources, and the community is building, so it is not easy for us now to move from Storm to Spark streaming, because there are a lot of work already done.
Yes, we need to take this port, and I think that we don't do this in production right now.
Yeah.
Thank you, guys. Sorry, we wish we had more time to ask more questions, but we're running short on next talk about 15 minutes. So thank you, guys. That was actually really interesting.
You're welcome.